Alright, what we're starting to look at here now is AC, or alternating current. Call it alternating voltage too, whichever you like. It's all about the fact that the signal, or we're now no longer using DC. If we had a graph of DC, for example, and this was time and this was voltage, then we'd just have a constant voltage. It'd be a nice DC voltage with the corresponding DC current. But we now have a alternating voltage, and we have it as a sine wave. This is what comes out of our plugs in our house. Now hopefully you definitely need to get this last unit that we've done on inductance under your belt. The electricity, the AC, I used to think was the more difficult part, but if you've got everything else, then it's not. So make sure you've looked at those videos, make sure you've done your homework and all the questions we've needed to do in class, because this unit won't be bad if you've done all that. Now, so we've got an alternating voltage, positive, negative, and that's what comes out. What happened was, in the 19th century, Nikola Tesla found that this was much more efficient for transmitting electrical power than the DC system. Thomas Edison was big on that. I might show you a little video on that, but the point was, this is very efficient for transmitting over long distances, which is what we do, and we pretty much still use the same system. Now, the basic thing you have to know about alternating voltage is what its peak value is, and what its average value is. And its average value we give an RMS title to, and if you've done stats, you'll know that the RMS value means root mean square. It's a way of taking an average type thing. I won't go into how we do that. We need to do a little bit of calculus to actually figure out what we're going to figure out with this. But what you need to know is that when you get the 240 volts, they're giving you an RMS value, so it's an average value. And the big thing we need to know with this whole AC thing is this, the square root of 2. That's how we're going to go from RMS to peak. Now, the smaller one, the RMS value is like an average. It's kind of like an average value. If we were to, and what we do when we actually figure it out, we won't do the calculus, but what we actually do is we go, okay, we've got this signal, it looks like this, let's square both sides, and then we sort of get a signal that looks like this. And then we take an average and we work it all out using integral calculus, and we get that square root of 2 thing, which basically says that the peak value here, actually we'll go back to our graph, which is a normal graph, because that was the square graph, wasn't it? So if we go back to our normal graph, what we're basically saying is the peak, which is obviously is bigger than the average, you need to divide the peak by square root of 2 to get the average. So peak divided by the square root of 2 will give you the average. Or the average times the square root of 2 will give you the peak. So we've got 240 volts as an average. So if we go 240 times the square root of 2, let's do that. Do the square root of 2 first, if I can figure it out on my calculator. Always use different calculators, and it means I'm not always that fast. But you guys should be really familiar with your own calculators. So this one here times 240, and I've got a value of 339.4. So we'll say that equals 340. So the peak, V peak, is 340. So if you're given a peak value, you divide by the square root of 2 to get the RMS value. And if you're given the RMS value, or the average, you multiply by the square root of 2 to get the peak. Makes sense, doesn't it? So that's the basic first thing you need to be able to do with this AC.